か。So just again, for the people that have just arrived, we're running just a little bit behind this morning, 11:45 start. If you want to tweet or X or whatever they call it these days about the talk, you can use the hashtags displayed on the podium, so PyCon APAC _2, or about the conference in general with PyCon APAC. We do encourage social media and photos as long as no one's wearing a no photo tag. Just to give you a minute.
10 minutes. じゃあ
Hi, everyone. We're going to start the talk now. So our speaker is Hayao Suzuki, and he's presenting Let's Implement Useless Python Objects, which kind of sounds like a lot of fun, to be honest. Before we start the presentation, he's just going to read a statement as a microphone test.
My name is Hayao Suzuki, and the title of my talk is Let's Implement Useless Python Objects. My presentation will be in English, okay? The presentation materials are in English. Hi. I will publish the presentation materials. I agree to having my picture during my presentation, and I will complete with the PyConJP code of contact.
So the presentation time is 30 minutes, 25 minutes for the talk, and 5 minutes for Q&A afterwards. Please welcome Hayao Suzuki.
Okay. Hello, everyone. And today I will be talking about let's implement useless Python objects. So let's begin. 喋りづらい。はい。So the presentation materials in this talk are available on my GitHub repositories. Also, the hashtag on this thread here and here. Here. Hi. Okay. Okay. Oh yes. Okay. Next, let me introduce myself. My name is Hayao Suzuki. And next, in kanji, Suzuki Hayao. Hi. My Twitter, X account here. Hi. And I work at BPRAD, a gold sponsor in PyCon APAC 2023. So let me introduce the BPRAD, our company. Our company, there are our services, Compass, PyQ, and Treasury. And so now we are currently hiring. So let's work with us. And recently, I published the translated book from Raleigh, Japan, Python Distilled and supervised translated book, introduced Python second edition in Japanese, and New Python 3 第2版, and Robust Python. This book is Python Distilled. Do you have it? Why? Thank you. Please buy this book on Amazon your bookstore. And this is my fourth time speaking at PyConJP or PyCon APAC. For the most part, I speak on topic I like. And okay. So today's topic, let's implement useless Python objects. So let's implement useless Python objects. Useless. So useless, okay? First, let's review the definition of the word useless. Do you know this word? Okay? So read as a quote from the dictionary, the Longman Dictionary of the Contemporary English. So first, not useful or effective in any way. Well, enable or unwilling to do anything properly. So I see that useless is a negative word of the useful. Oh. But I would like ask about you here. So it's useless. It's really useless. Ready? So let me quote from the ancient Chinese philosophy. Philosophy, the Chinese philosophers. So I can speak Chinese. Sorry, in Japanese. 創始 人感性変 So this Chinese was an ancient Chinese text. So in Japanese, 人を皆有用の用は知れども無用の用を知ることなきなりと in Japanese. So in English, everyone knows the usefulness of the useful, but no one knows the usefulness of the useless. Repeat after me. Everyone knows the usefulness of the useful, but no one knows the uselessness of the useless. Okay? Understand? Yes. Okay. Perfect. So what does it mean? So let's implement the useless Python objects. So the useless objects are useless. So, but how to make a useless object? It's very useful. Chinese philosophy says so. Useless objects are useful. Today's theme. Next, Okay. Okay. Yeah. What's the Python useless Python object? For example, a layer container. So layer container has spam, egg, bacon, but spam in C returns false. Oh, he's liar. So and tomato in C is true. Oh, layer container does not have a tomato, but tomato in C returns true. It is a liar container. It's liar. It uses Python object. Next, Fibonacci size. So Fibonacci size has a range of 50. So I will expect it return the range s equal to 50, but big integer returns big integer. So 50 is Fibonacci sequence elements. It's two big integer. Next, so shuffle interval. So shuffle interval has 1, 2, 3, 4, 5. So I will expect it in four explain. So 1, 2, 3, 4, 5. But 5, 3, 4, 2, 1. 4, 1, 2, 3, 5. 2, 5, 3, 1, 4. So it's a shuffle. So this is a useless Python object. So useless Python object in this talk, a useless Python object behave Pythonic. That does not work as expected. So a useless Python object works. So, but does not work as expected. Okay. Okay, next. So, by the way, so Python has a Python has a basic common data structure, list, tab, dictionary, and set. There are different data structure, but they have common operations, len function in statement for statement. So this len function in statement and for statement are a common operation in data structure. So this basic data structure, these operations. So next, how to implement those user objects and first and contains. So container object is equal to the object has done the contains method. So for example, layer container, the implementation is here. So layer container has done the contains method, but returns not in self data. This source code is not perfect. Not perfect. My GitHub repository, my GitHub has compared to source code. Okay. So layer container has the contains method. So it is simple. Next, len. So len function and size. So the size of object is equal to the object has done the len method. So this one, so Fibonacci size the object returns the Fibonacci sequence. Do you know Fibonacci sequences? Yes. Right. So phi is equal to golden rate. Okay. Hi. Next, for and iterable. So iterable is has a done the iterable method, and the method is iterable. So shuffle iterable has done the iterable method. It returns a shuffled iterator. So okay. So I speak about data container. So how to implement Python objects? So we need understand object protocols. So object protocols. For example, collection database is very useful. This model provides arbitrary-based classes that can be used to test whether a class provides a particular interface. And so ABC size, abstract basic class size is equal to len method. Container abstract basic class is equal to the contents class. Iterable has done the iterable method. And collection abstract class is equal to size and container and iterable. So collection. This collection object is equal to size, content, and iterable. So useless collection is Fibonacci size, layer container, shuffle iterable. It's okay. So this is a useless Python object. So on the collection and ABC and built-in object, so sequence is called built-in Python object is tuple, and mutable sequence is list. Mutable set is set, and mutable mapping is dict. So next, more difficult example, modular sequence. So sequences requires the dunder get item method. So the dunder get first if statement has a single key object. So return the key and modulo len side self data. Next, elf statement key slice is a slice, but size modular calculation. So this sequence, modular sequence, is infinity sequence. So, for example, sequence equal modular sequence range 20. And so print sequence 21:44. So if this sequence is tupularized, this sequence 21:44 is empty list. But modular sequence returned 1, 2, 3. Next, print sequence I can't read the number. 65? わかんない。はい。But print but and return 3. So this modular sequence has not this key, but this modular sequence returned 3. And the sequence count 13. So this method, the number of elements of the arguments. So, but this sequence count 13, it doesn't stop. It's infinite loop. Next, misspelled dictionary. So this done the initial method, shuffle the keys, shuffle values, shuffle has bars. So this is misprinted. So misprint dictionary A colon 1, colon B colon 2, C colon 3. So for key in D, so the C colon 1, B colon 2, A colon 3. This is shuffled. So next, a cross set. So cross set has the initial and the lambda less than method. So this data structure at point is a lambda less than method. So cross set, so X bacon span and X span. So S less than T is true. So this is not correct, but this object is true. Hi. So it was a bit less. So I will summarize. So we have implemented a user's Python object. So the object it's useless, but the way it is created, how to create it is useful. So also use collection ABC module is very useful. And so You understand object protocol, so you can do anything. Thank you. ありがとうございました。
Thank you so much for the talk. Does anyone have any questions about these wonderful useless topics?
すみません、日本語で質問していいですか。この話の中で結構その役に立たないオブジェクトが出てきていまして、実際どういうところでそれが役に立つようになるかっていうのがなんか実例とかありますか。
日本語で書いてほしいですか。
お願いします。
本当に今回実装したオブジェクトそのものが役に立つことはほぼないです。役に立つですが、例えば、この普段使っているこのフォー文とか、どこするかな。ただ普段使っているメソッドとか、そういうフォー文とかどういう特殊メソッドに対応しているかっていうのを知っておくと、いつか役に立つかもしれないぐらいです。
かもしれないってことですね。なるほどですね。でもう一つ質問なんですけど、シャッフルドアイタルブルっていうやつがあるんですけれども、なんかその前のやつで、これ何が問題なのかちょっと理解できないんですけど、なんかちゃんとアイタルブルがシャッフルされてるからなんか問題あるのかなって思ってて。
名前が矛盾してるってことですね。違う、矛盾してない。むしろこれは役に立つんじゃないかっていう、いいことに気づきました。いや、僕が作った役に立った中で実はこれは役に立つんじゃないかなって実はちょっと思っていて、
なんかこの中でほぼ全部役に立たないなって思ったんですけど、これだけなんか役に立つなって思って。
この発表の根底を覆す
ごめんなさい、すみません。
とてもいい指摘で、
これはどういうところで役に立たないかっていうのを教えてくれますか。
そうですね、なんだろ
う。むしろ便利すぎて。
どちらかというと、そっか、なんか今回はちょっとシャッフルイタラブルっていう分かりやすい名前をつけてしまったので、よくなかったかもしれないですね。
ありがとうございます。
Any other questions? Did you want to translate that for English, or is it too hard? Roughly.
I can 日本語でも話してもいいけど、Should I ask a question in English? Right.
If you can, that's great. If
I will speak both Japanese and English, right? So 今のシャッフルドイテラブルの話でちょっと思い出したんですけど、思いついたんですけど、これってセットっていうの集合って別に順番って関係ないはずなんですよね。
そうですね。はい。
だから別にこれ何も問題ないっていうことですよね。だけどわざわざシャッフルしてるっていうのが無駄をしているっていう、ただそれのSo in English, so I think that when you use set, the element of the set has no orders. So shuffle, even if it's shuffled, it behaves like a set. However, using random here is useless or burden to some kind of burden. So it's sometimes I can say it is useless. コメントでした。
Finished? Any other questions? Anyone? We've got time. We're running ahead of schedule. So now. we're actually running closer to real schedule now. So, nope, nothing else.
Did I translate my question and the answer?
If you want to, it would be great.
So basically, my question was that the shuffled iterable function, it's actually shuffling the iterable, so it seems very useful with lots of use cases as compared to the other functions that do not seem very useful. And the gentleman couldn't answer that question, but this gentleman answered it by saying that since it is a set and a set does not have an order, shuffling that unordered set has no use inherently. So it is a useless function.
Was the set in the other, was in the example, wasn't it, rather than here?
Yeah.
Yeah, okay. Awesome. Okay, if there's no more questions, we're pretty much done. So if you've got more questions, you can track them down in the hallway. Lunch was going to be delayed, but it should still be out there, so you're welcome to get started, and you can bring the food back in here. The rest of the day is back on normal schedule. If you can stop by and visit the sponsors and do the towel rally, that would be awesome, and collect all the stamps, because we love our sponsors. Yeah, let's give a final round of applause for Hayao Suzuki.
ちょっとしたご連絡です。次のトークは13時30分開始なので、あと30分くらいあります。この部屋で待っていただいても大丈夫ですけれども、スポンサーブースがこの階の隣の部屋だったりとか、受付の向こうにあったりするので、よければスポンサーブースの方も行ってみてください。いっぱいスポンサーブースあって楽しいですし、スタンプを集めるとですね、このとても使い勝手のいいタオルがいただけちゃうので、数が少なくなっておりますので、もし興味ある方はお早めに。イングリッシュバージョン。Next talk will start at 1:30, and we have plenty time, so you can waiting start. This room is okay, and also sponsors will have their own booth. There are many sponsor booths, and it is very fun, in my opinion. I recommend go to sponsor booth and get this wonderful towel. Thank you.
Hi, everyone. Welcome. If you want to share about this on X/Twitter, please feel free to do so. You can use the hash PyCon APAC _2 hashtag if it's about talks in this room, or you can use just hash PyCon APAC for the conference in general. And we absolutely appreciate all of the social media that you give us. So we'll be getting started shortly. Today's session is presented by Anthony Shaw, and is well displayed up on the screen, is about parallel code with Python 3.12 sub-interpreters. Before we get started, Anthony's going to read a statement to effectively do a mic check, but also provide some information about his shares. So just flick your mic on.
Yeah, my name is Anthony Shaw. The title of my talk is Parallel Code with Python 3.12 Sub-Interpreters. My presentation will be in English. The presentation materials are in English, and I will publish the presentation materials. I agreed to having my picture taken during the presentation, and I will comply with the PyConjp Code of Conduct.
We've just got a few more minutes before we start. Okay, so the presentation will be 30 minutes, including the presentation material, and 5 minutes for Q&A. So please welcome Anthony Shaw with a round of applause.
Okay, hey everybody. So I'm Anthony. We're going to talk about sub-interpreters in Python 3.12 and also look a little bit forward into the future. Before we get into the talk, a couple of things. A couple of things about me. Okay, so a few links. That's my website where my blog is, links to talks I've done previously and stuff like that. I'm on Twitter, Anthony PJ Shaw. I'm also on Mastodon, on the Fostodon instance. That QR code, which will be on the last slide of this talk as well, has some links as well as copies of the code snippets that I'm going to show during this talk. So we're going to talk about subinterpreters and parallel computation in Python in this talk. And I've got an analogy that I've been working on, and I'm not quite sure about it. So we're going to talk through this analogy. Hopefully it's going to help us, because when we talk about subinterpreters, it's really important to consider the time it takes to create them and to serialize tasks. So to give you an idea, this is a concept that we have an individual who needs to review 3 books. So that's their work that they have to do. They've got 2 friends, and if they review a book by themselves, it takes 60 hours. So if they review 3 books, one at a time, it would take them 180 hours. So you might think, okay, can we do this computation if the person is a CPU and we've got 3 CPUs? Can we do the computation in parallel? So what would it take for 3 people to review 3 books? So you think, okay, that should take 60 hours. So if this were a math question, that's probably the right answer. This is a computer science question, so that is the wrong answer. The reason it's the wrong answer, in my analogy, is because they have to package the book, they have to ship the book, and then the person receiving the book has to unpackage it. So I'm going to give you another example of this. I've got 3 pieces of paper here. I am CPU 0, so I'm the main CPU. I'm busy because I'm giving a talk. I've got some work to be done, which is to fold these pieces of paper twice. And I need some volunteers from the audience, if you put your hands up. So I want you to fold it half and then half again, okay? One volunteer, 2 volunteers. Okay, right, go. So I've got to give you the job, and somebody else. And then the next person. Okay. Okay, and then when you folded it twice, come and give it back to me as well, because I need the result. Okay, so in that example, we had our parallel computation. Was that quicker? No. Why was it not quicker? Because it took me longer to run to the person. So we'll talk about what would be the 4th CPU a bit later in the talk, which is, I guess, the long pole in the tent. There's other words for it, but yeah, it's the slowest one. So the actual time for the 3 people is the packaging, the shipping, the unpackaging, and the review time. So this does relate to some real scenarios, but it's really important to consider this. So the actual CPUs themselves are all more or less the same. We saw that one of them was a bit slower, but it takes me the same time to fold the piece of paper twice as it would somebody else. Okay, so the thing doing the job was the person in this analogy. The work to be done was a stack of books or the pieces of paper. And the interworker communication was me running with the task, giving it to the CPU, and then the person bringing back the result. That part is really important, and that's actually one of the most important things when we look at subinterpreters. So a couple of questions. So our book editor has a 4th person to review books. Would that shorten the time to review 3 books, assuming that you can't cut a book in half? What do we think? Show of hands for yes? Okay. Our editor has decided to ship the books by plane. Would that shorten the time to review 3 books? So instead of shipping them by truck, they're going to ship them by plane. Do we think that'd be quicker overall? Mostly yes. We've got some nods. Okay, good. So let's relate this back to Python. So in Python, we have a few options, and I've included subinterpreters because that's what we're here to talk about. At the moment, when you want to run things in parallel, we have a few options. There is a difference between parallelism and concurrency, which I'll talk about in a second. But when you want to run things at the same time, let's use a non-technical term, you have some options. The first option is threading, and I've put a star there because it's parallel, but we'll talk about that. Coroutines with things like async IO, which is great for concurrency. Multiprocessing, has anybody used multiprocessing before? Okay, quite a few of you. Okay, great. Multiprocessing is properly parallel with Python. And then subinterpreters. So the third column along is the startup time, which is important. So the fastest is coroutines, then threading, then subinterpreters, and then multiprocessing. And I'll put some numbers behind this as well and actually show you to what extent that's true. Also, the data exchange is really important. So in the case of the folding the pieces of paper or the book, in the case of the book, we're not reviewing the same book at the same time. I've actually got to go and give you the book. And it's the same with multiprocessing and subinterpreters. You have to package the data to send it to somebody to look at. So threading is great for, and coroutines are great for small IO-bound tasks. So IO-bound would be things like sending data over the network, reading and writing from files, things that need some kind of IO activity. It's great for concurrency or parallelism in those jobs. Multiprocessing and subinterpreters are better suited for CPU-bound tasks. So if you've got a workload on Python and you've built an app and you've noticed that you've got a 4-core CPU, and I would love to show this GIF, but I'll put it in the link. It's a breakdancer who's CPU 0 and everyone else standing around clapping, which is CPUs 1, 2, and 3, and 4. Just 3, actually. So if you have CPU or IO-bound tasks and you want to run things properly in parallel, we've got other options. So here's a small, simple diagram to demonstrate the difference between concurrency and parallelism. So in concurrency, you can start multiple tasks at once, but only one of them is truly actually executing at any time. In parallel, multiple can be executing. So when we say executing, this is for a multi-core or multiple CPU environment. Multiple CPUs or multiple cores are actually doing work. So I had a star next to threading. So let's talk about an example of where you would hope to get a performance gain from using threading. If you've used threading in other languages, you would probably expect the implementation we're going to show to be faster. So in Python, our task is for every integer in a vector, calculate the distance to 50. And we're going to generate random numbers between 0 and 100. We're going to generate 100,000 of them. And my crude implementation is to loop through each number and then work out how far that number is from 50. So that is a linear problem. Could we make this faster by chunking that information and then doing it multi-threaded? So in Python, I've got 2 implementations. The first one is the crude one that I showed you. So f-linear is the just go through a loop. And then my second implementation is f-threaded, where I'm going to split it up into 100 chunks. And then for each chunk, I'm going to start a thread, start all of the threads at the same time, and then each one's going to calculate their answer, and then I'm going to wait for them all to finish. Okay, so show of hands, who thinks implementation 2 would be faster? All right, this is a good audience. It's twice as slow. So a few things here that's going on. One is that there's a lock in the interpreter. So even though you've got multiple threads running, they're all running in the same interpreter. And they're running kind of concurrently, but they can't run at the same time. So this lock is what subinterpreters are about. And it's basically about moving the lock so that you can have things running in parallel in threads as well as in subinterpreters. So what is a subinterpreter? So it's an API for creating 2 or more interpreters in the same Python process and then running each one in parallel. It's part of the effort to make Python better at running parallel code. It's developed by Eric on the Faster C Python team. Eric works at Microsoft. And this work, and I added this last week, PEP 703, if anyone's heard about this no-GIL discussion, and that's been going on for a couple of years now, this does contribute towards the no-GIL effort. It is not a competing implementation of no-GIL. They do work hand in hand, and one of the reasons for that is because I'd say a large chunk of the work to make subinterpreters happen has actually been removing global state from C modules. And that needs to happen anyway, so it's great that Eric's had a head start and other people have been testing this. So if we could give you a system diagram for Python 3.11 and below, at the top you have the Python process. Underneath that you have really a data structure, but something called an interpreter. And then underneath that you can have threads. So when you have one of each by default. So you've got the main process, you've got the main interpreter, and then you've got a thread. When you're running in Python, you can start multiple threads, but they're all running in the same interpreter. The GIL is the global interpreter lock. It technically belonged to the interpreter, not the process, but there was no way to have multiple anyway. So for the sake of simplicity, the GIL, the lock, belongs to the Python process. When you use multiprocessing, you're basically starting multiple processes. So with subinterpreters, that lock, the thing that only lets one thing run, now belongs to the interpreter. And you can start multiple interpreters in the same process. So in the case of our threading example, if you were to start, yellow means running, I guess. So on the right-hand side, in that example, you can have 2 threads executing code on different CPUs at the same time. So if we were to re-implement our NumPy distance to 50 algorithm and use the same threading example, but have multiple subinterpreters, it would be faster. So how would you use a subinterpreter in Python 3.12? Okay, first of all, you have to import a super secret module called _xx subinterpreters. In most of my examples, I've always aliased it to interpreters because otherwise it looks ridiculous. The reason it's called _xx subinterpreters is because you're not really supposed to be using it yet. It is mostly there for testing purposes as an experimental interface. The other thing you might notice is that, well, first of all, this is a blocking call. You wouldn't notice that. But when you run the Python code, that code is a string. Now, writing Python code all in strings is not much fun. It's hard to use an editor. You might think, OK, I've got a function already. How do I tell it to run that function? But you've got to copy the code of that function and convert it into a string. So at the moment, the API for subinterpreters is pretty basic, but it's going to improve soon. So the Python interface of subinterpreters for 3.12 is really a sketch, and it's mostly for testing. I'll talk about what that will look like in the future in a second. Another thing to note is that when you call subinterpreters.run, that is a blocking call. So that's not running asynchronously. It will hold the process that you're calling it from. So it's not doing anything in parallel, it's just running it. If you want to do things concurrently, then you would start an interpreter from a thread. And I know in my diagram I had the threads underneath the interpreter, but we're actually using a thread to start an interpreter. And the reason we do that is because we can basically create proper parallel examples. So you would create a thread, and then you would ask it to run interpreters.run, and then give it the code to execute. OK, so that is the current API. the proposal that might be in 3.13 is that you would have things like a function that you've defined in Python code, and you'd ask it to run the function in a subinterpreter. So that's a lot easier to use than strings. So accept a callable, similar to how the threading interface works at the moment. Another thing that should happen in the future as well, hopefully in 3.13, is a executor context manager. If anyone's ever used one of these for threading pools, you create a pool of threads, you have a series of work to be done, and then a pool manager kind of manages which task to give to which thread. And then if one thread finishes, it gives it the next task, and it basically goes through all of them until it's finished. So we will see something that looks like this pretty soon, where we've got an interpreter, a pool, and you have a bunch of work to be done, and you can ask that pool to go and do the work. And it will do that in parallel. OK, so this is great. Is it faster? So these are some graphs from my master's thesis, which included a whole bunch of work on testing subinterpreters. And the first thing I wanted to test is how long does it take to start one of these compared to the other options. So on my graph, the axis is the amount of time it takes the mean time to run it 100 times. Threading is by far the fastest to create a thread. Subinterpreters are slower by quite a large factor. And then multiprocessing is extremely slow. So this shouldn't be a surprise to anyone who's used multiprocessing, but creating a Python process takes a lot of time. But I think if you compare threading, I've just used as a balance to show you how fast threads are, but they're not actually parallel, so it's kind of irrelevant. Subinterpreters are significantly faster to create than multiprocessing. OK, so that's when you create one that does nothing. So in the second benchmark, I've asked it to calculate pi, or someone corrected me earlier, it's actually pronounced p, to 200 digits concurrently 10 times on a 4-core CPU. And you'll notice that threading and subinterpreters are similar. And why is that? Going back to the folding the piece of paper twice, it's because the job to be done isn't really big enough to see the benefits of the gain of the parallelism. So when I change it from 200 digits to 2,000 digits, subinterpreters is faster than threading running on a single CPU, because the benefits of parallelism have kicked in. So going back to our book timeline, so we had the packaging, the shipping, the unpackaging, and the reviewing. The person 1, CPU 0, then packages the second book and sends it off. And then they review the third book themselves. So the question was, our editors enrolled a 4th person to review books. Would that shorten the time? The answer technically was yes, because you'd actually ask the 4th person to package the books, freeing up the 1st person to review the books. That relates back to our Python example, because often you actually want one CPU to be dedicated to actually managing the tasks and not doing the work. OK, so in Python terms, you've got pickling, spawning, unpickling, and processing. And that's what that would look like in that case. OK, so which option is best for you? So I've reduced this down to a couple of graphs. Now, if we have the size of task, so the amount of computation that needs to be done, going from smaller to bigger, and then the time it takes to execute, going from faster to slower. So the bigger the job, the longer it takes to run. Everyone understands that? So that's normal execution. If it's threaded, it takes slightly longer because you've got to create a thread, but it's still linear. That distance is the startup time. So with multiprocessing, the startup time is significant. But if you had 2 CPUs, at some point those lines cross, could you get the benefits of parallelism? So if you compare that with subinterpreters, the startup time is smaller, therefore the benefits of parallelism kick in sooner. Okay? it's really hard to quantify what that point is because the amount of work to be done is difficult to measure. I can't give you a number because it depends on the CPU, depends on the architecture, like there's so many factors. Okay. And when you add more CPUs, the benefits of parallelism make a bigger difference. So that line is basically at a different growth rate. So if you wanted to reduce the cost of starting a subinterpreter, similar to multiprocessing, you'd actually probably want to reuse them. So in this case, we've had you start one, it says it's ready, you give it a job, it gives you back a result. You start another one, it says it's ready, you give it a job, you get a result. What you really want to be doing with subinterpreters and with multiprocessing is to reuse the same one. So once it's started, to give it a second job and keep it running in the background. Okay, so in summary, multiprocessing is a great way to run parallel work, but Python processes take a long time to start. Threading is fast. It's really fast to create a thread. It's really easy to use them, but they aren't truly parallel because of the GIL. Subinterpreters are a happy medium, and they're much closer to the startup time of threads than they are to multiprocessing. User-friendly interfaces and APIs should be in Python 3.13. So if you're hoping that you can use this right now, the answer is probably no, unless you are using it from a C API. The C API is usable, but the only types, there's a lot of caveats to that. The only types that you can serialize and send to the subinterpreter is very narrow at the moment. So you can do floats, bools. You can't do tuples. You can't do dictionaries. So the data that you can actually send to a subinterpreter at the moment is pretty limited. You pretty much have to pickle everything and send it as a byte string. So that's kind of one of the big constraints at the moment is actually how you send it data and then how it sends the data back. And the fact that you have to start them using strings. So luckily in Python 3.12, you can do nested F strings. So if anyone was wondering, why on earth would I ever want to do that? The answer is because when you run interpreters.run, the string can be an F string that contains an F string because the F string inside it is the code that you want to run. So there's a perfect use case. Low-level libraries written in C need to compile in some support. So they should test subinterpreters. So if there's anyone out there who maintains a Python package that uses the C API, I strongly advise A, that you test it on Python 3.12, and B, that you test it with subinterpreters, because there are some changes. And I found that out the hard way. Here is the QR code with some links, copies of the code snippets, as well as links to the benchmark code, which is a Jupyter notebook, if you want to have a look at it. Cool, thank you.
Thanks so much for the talk. It's awesome. Any questions from the audience? Anyone? I feel like this is going to be a busy one. The microphone's coming.
The first question is from a C Python core developer, so this is going to be...
Oh, this will be fun.
Thank you, Anthony. This is a very nice talk. And as you comment, the subinterpreter provide a very limitation data exchange between the subinterpreter. So it cannot using the data exchange of the multiprocessing way or threading way. So what do you think that what will be the best use case for the subinterpreter from the end user side?
I think if you've got one workload that I've been looking at is GUnicorn. This is an example of what a use case I think would be effective. In GUnicorn, there's different ways of running it. A common way is multi-worker, multi-thread. Multi-worker is a process pool, and then inside of that you've got threads, thread pools basically that sit in each process. The other option is a unicorn, which uses a lot of async. You'd notice that a multi-worker, multi-thread approach to G-Unicorn, each Python process has quite a significant memory overhead. Subinterpreters have a far smaller one. So my theory, and I'd like to implement this, is that you could write a G-Unicorn backend that uses subinterpreters, and you'd get a lower memory footprint, and also creating interpreters would be much faster. You do keep them running, so that benefit, I think, would more be to do with like scaling around, but the memory footprint would be smaller. So it's a smaller memory footprint is one thing. The time to start them would be smaller. So I guess it comes down to what is the work to be done, and is that work to be done big enough to see the benefits of parallelism? In terms of serializing and sharing the data, there is a shared memory interface. It's just not finished yet. So the serialization into that shared memory space, there's lots of different types which need to be implemented. Tuples would be a good example. So floats and balls and things you can do at the moment. But beyond that, it's quite limited still.
Okay, thank you.
Okay.
Yeah, I think we're going back first, and then we'll come back forward.
Oh, yeah, sorry. I'm curious about how to coordinate graceful shutdown of sub-interpreters when you have multiple threads running individual interpreters, for example, delivering signals from the main program to shut down them or things like that.
A very good question. I have no idea. The exception handling as well is a big question mark for me. Yeah, like how, if an exception is raised, I think it basically stops the interpreter and causes like almost like an exit code in that interpreter. How you extract that exception, though, I don't know. In terms of graceful shutdown as well, that is a really good question. I would love somebody to test that. Like, if you implemented a dunder exit magic method on a type, would that get called from the subinterpreter or the process? I'm just asking you questions now instead of the other way around. But yeah, good question. Maybe tomorrow at the sprints we can try it.
All right, we've got time for probably one or two more questions. So up the front. Yeah.
Hi, thank you for the talk. So when when eventually the sub-interpreters are ready with the more user-friendly interface, should we all stop using multiprocessing and shift over to sub-interpreters?
I think so, unless there is something that really needs to be isolated in a separate process. I can't think of any examples, but yeah, I think so, yeah.
Thank you.
Did you do any performance comparisons between this new way of running multi-threaded code in Python and just writing a straight-up C++ function and then calling it?
Well, I mean, in the Py example, yeah, C++ would be significantly faster. No is the answer. I do have, that is in my thesis actually, is a whole bunch of comparisons with different implementations. And the summary of my thesis as well is that Python is getting faster, but in terms of how it impacts the scientific community, so much of the back-end modules are now written in C and C++, that I think they are still pretty effective and efficient. The issue, the bottleneck really is about how they can be run in parallel, and this is one of the things that would open that up.
Thank you.
I think one more, just up the front here. Wait, in front of you. All right, that one I'll do.
Hello, maybe a clarification. When you start a sub-interpreter, does it start blank without any modules loaded, or with modules loaded, with your current code loaded, with your current variables and data already copied over? Like, what is actually there?
Okay, so it has its own state. It has the, if you're familiar with site, the site import, it runs that, so it has the standard library, and it would also have access to modules that you've got installed in that environment, but it won't have those imports. So it wouldn't have, yeah, it pretty much doesn't have anything that the main interpreter would have, other than the site. Yeah.
So it is actually possible it would be slow as a multiprocessing, because multiprocessing copies, like it forks, so it keeps your current state.
It doesn't fork anymore. It used to, yeah. It has its own, and it also does the site import. And it has a whole bunch of other overhead to create, basically spin up the memory allocator and a whole bunch of other things that subinterpreters doesn't have to do. Yeah.
Okay, that's all we've got time for. If you've got more questions for Anthony,
I've got a simple question.
Sorry, we don't have time at the moment. We've got to stay on track. Sorry. Catch him in the hallway afterwards, which is what I was about to say. So he'll be available whether he likes it or not. So please ask your questions out there, and don't approach the stage, please. Thanks. Just one more announcement. Party registration is now open, so if you have a ticket for the party tonight, please make your way to the registration desk and pick up your wristband. Hi everyone, welcome. If you'd like to tweet about this talk or X about this talk, whatever we're calling it these days, use the hashtag PyCon APAC_2, or if the conference in general, PyCon APAC. Sorry, 1 second. So our speaker today is, I hope I get this right. Chuk Ting Ho.
Hi.
And the topic is reformatting your code without AI. Let's see how a formatter works, which is a nice change from all the AI talks.
Oh, really?
On doing this. Maybe not today, but in general.
Yeah.
So before we start, Chuk's going to read out a statement as a mic test.
Yeah, I have this.
So if you want to go ahead and do that now.
Okay, so I will read this out to start. Hi, my name is Chuck. The title of my talk is Reformatting Your Code Without AI. My presentation will be in English. The presentation materials are in English. So I will publish the presentation material, which you can access via that link. And I agree to have my picture taken. Please do and put it on social media. During my presentation, I will comply with the pyconjp code of conduct, which is very important. Thank you.
Okay, so the presentation talk time is 30 minutes, including 5 minutes Q&A, depending on timings. So with a round of applause, please welcome Chuk.
Hey, thank you. So again, this is the most important slide of the whole slide deck because via that link, you have access to the whole slide deck. I'm trying to speak a little bit slower. Part of it is because my voice is not very good after the serious drinking yesterday. But also, if you think that I speak too fast, please, let me know. I am happy to. I understand not everybody's first language is English, including me. So let me know if I can help you to understand. So. Yeah, also I have social media. Feel free to take picture and post online. I'm going to tell you about how to reformat your code, not with AI. So it's gonna be interesting. So first of all, I'm Chuck. I contribute to open source. So I love going to Sprint. So please come to the Sprint tomorrow. If you haven't registered, you should do it now. I organize a lot of events for the Python community. Right now, I'm the Python Software Foundation Director and Fellow. So hopefully, after this morning's keynote, you know a little bit about the Python Software Foundation. I'm also working as the Community Manager of the OpenSSF. I can tell you a little bit more about it. OpenSSF is part of Linux Foundation. We focus on open source security. We are not a for-profit company, so we are not trying to get your money. We have newsletter and blogs, so if you care about how to develop safe software, you should follow us. There are free courses you can study without paying, so there's for you. Feel free to talk to me after if you want to know more. I'm also going to give another talk at the unconference later, so you can also come to that. But let's go back to this talk. How many of you will write code with another person? Yes. I hope that is a person, not the co-pilot, that maybe some of you will be using as well. So AI is a very popular thing nowadays. I try a little bit myself. This is me using ChatGPT. I asked ChatGPT, can they format my code? So ChatGPT said, yes, I can. Give me your code. So I give them my code, which I copy from the internet. So there you go. This is the result of the ChatGPT reformatting my code. Can you see something wrong? Who sees something's wrong? It's too small, maybe. Don't worry, I have found it and pointed out for you. It's missing a close parentheses. But ChatGPT said, I have fixed it for you. No, it's making things worse. So this is just one case. I'm not saying that ChatGPT is always wrong, but it's not always right either. So we don't need to use AI to reformat our code. There are good formatters available. Can you name some of them? Black? Rough? Oh, it's the new one. So Black, PyBeta, or Autoflake, iSort. How many of you are actually using them? Nice. How many of you know how it works? Okay. Do you want to make one yourself? But I'm going to show you anyway. So, chapter 1, how to analyze a Python code. We want to represent the code in a structure, so it's very easy to understand. So one of the way to do it is to use abstract syntax tree. So abstract syntax tree would be something like this. So this is a line of code. In an abstract syntax tree, it will preserve all the key elements in the code that explain how it works. You can see it has a function call, it has the name of the function, has the parameters of the function, but that's it. Comment doesn't matter. White space doesn't matter, well, unless it's at the beginning. So doesn't matter. So it's useful if you are writing a compiler or interpreter. CPython is an interpreter, by the way. So it's for analyzing the syntax. So it's, we call this type of analysis a static analysis. We write some code to look at your code and to try to optimize it a lot of times. For example, some compilers would optimize your code so that when it got executed every time, it can save some time. So a lot of times, these compilers need to break down your code into a tree format and then maybe restructure it, keeping the functionality of your code, but make the execution faster. So an abstract syntax tree will keep the essence of how your code works, but it doesn't care about the details, like the comments and the trailing white spaces, or some spaces in between that doesn't make your code wrong or can't be executed. So abstract syntax tree doesn't care about that. But if I'm writing a formatter, right? For example, Black will try to follow PEP-H or what the community usually do, to have some white spaces there to make your code more readable. So abstract syntax tree in this case is not very helpful. We need to use concrete syntax tree. So this is an example of a concrete syntax tree. You can see it's still showing more of the details of how your line of code looks like. It will show you the, for example, the parentheses. So if you have extra parentheses, it will show up in your concrete syntax tree. But can you still spot that it's missing something? It is still missing the comment and some of the white spaces. Still no white spaces. I want the white spaces. So how do we do this? We need another tool that can show me all the details. One of these tools that show me all the details is libcst. But not all formatters use libcst. Of course, Rough is not using libcst because it's written in Rust. Even Black is not using libcst. But for me, it's a very good example because it's very easy to use, and I do use it to have fun, which I will show you later. So this is libcst explaining to the user what it does. So it's not very updated, as you can see. Hopefully, they will update soon to 3.12. It's a CST, concrete syntax tree, that keep all the details, including the right spaces, comments, and parentheses. This is very useful if you are building some refactoring application or a linter, because if you are writing a linter, you want to check everything. This is what a tree that is built with libcst will look like. You can see it's getting more complicated. It has the white space, of course. Even the comment has been saved in the tree, so you can see it in one of the branches of the tree. So now we have our tool ready, so we can parse our source code. This is an example of using libcst to parse a very simple expression. So you can see I have 1 plus 2. It's a binary operation. But using libcst, you can see all the details has been preserved. On the left-hand side, there's an integer, it's 1. Operator is an add operator. There are also white space before and after the operator. And then on the right is an integer, that is 2. So we can parse our source code, it's a good start. What's next? Next, we want to find the part of the code that we are interested about. Imagine if you are now creating a reformatter. The trees generated by libcst is very big. Before you see the very simple expression become many, many lines. Imagine if you have, let's say, a few hundred lines of code. It will be very big. So not all of the code we do care about. We want to find the points where we want to work on. So we will use a matcher to do that. We will also use a visitor, which I will show you later. A matcher is, like the name suggests, it matches your code with some of the characteristics that you have defined. It's quite flexible. You don't have to say all the detail. It will immediately find that part that matches what you have defined. You can use some logic, like 0 or more, 1 off, or at least number, like for example, at least 3 of them. So that's more efficient than using an instance to check every single detail. This is an example, which I'm going to show you the real code. But let's have a look first. This one is checking whether the node is a binary operator, specifically an add operator. So let's look at the code. This is the code. Can you see? Yes, not so much. OK, bigger. So sorry about that. I'm using dark mode on my computer, and not so good for you. I'm sorry. So at the beginning, I write this matcher is a function that it will use the libcst matches to match the node, whether it's a binary operator, which is an add operator. And then I have an expression, which I have written down This is just like the 1 plus 2, so it's the same. And then I try to see if it matches that have a plus operator in between. So let's run this code. It's true, so it matches the 1 plus 2, which is this expression. So this is not that interesting. But if we use it later, you will see the power of it. The second thing I want to talk about is the visitor. So visitor is a function that would transfer your code. It will go down the tree that you have generated, and then every time it enters a section of your code, you can do something about it, but you can't change it. You can only travel along your code and pick up some detail and save it somewhere. So, for example, I am counting how many add operator is in this expression. So I'm going to run this code, and you will see how it works. So this is the code. So every time it visited an add, it will add the count by 1. So I will also show the current count, and then it will say goodbye when it leaves the add section. So I have 1 plus 2, and I will first of all pass this expression into a module, which looks more like this here. So this is the module. So after the parsing, it will look like that. And then I will use a visitor to visit it to see how many section we have entered. So let's run that. You can see we have 1 plus 2, so it only have 1 add section. Let's change it up. Now, I have 1 plus 2 plus 3, and I will have 2 add section, which is 2 add binary operator section. So this is how it works. So what does this lead to? Last thing, we can change the code. So now we know how to visit the code, pick up the details. Maybe with the help with matching, you can change the code. So visitor read only. So now we need another one, which is transformer, that can change the code. So transformer is not read only. You can read or write. It will also go through the whole tree, visit the node 1 at a time, like the add operator, it visits 1 at a time. You can also update the node. This is how it looks like. So I have op by 1, which is doing something very wicked. It will enter the binary operation, check, so I will also show you this function later. It will check whether it's an add operation, and then change it to add 1 more to it. So let's look at the real code. Here. Right. So first of all, I have a matcher. That match, if it's a binary operation, that involves 2 integers and a plus operation. So every time I finish a binary operation, I would check whether it has 2 integers and a plus operator. Everything that matches that means that is the first part of the addition, because in the later part of the addition, it will not have 2 integers. It will have an operation and an integer. So now I can update the node. Instead of having 2 integers, I change the left side into an operation with 1 and whatever that was there originally. So what do I mean? Let's say I have 1 plus 2 again. This time, it will add an extra 1 on top of it. So let's have a look. Ooh, it changes. So this very wicked reformatter will change your code and add a 1 to it. It will work even if you have more than this. So let's say 3, 2, and 4. So this time, can you guess what's the result? It's 1 plus 3 plus 2 plus 4. So whatever you have, it will have a 1 plus. So it's always off by 1. Now, let's revisit this and see the last part of the puzzle is to generate the source code. How do I generate the source code after I do this very wicked operation? It's very easy. Remember at the bottom of my code, it has new equals to module.visit. So new will store the new module that has been modified. And then you just call new.code, and you will have the updated source code. Let's see it again. Here we have this source code. Let's change it up again. So just to show you, I haven't pre-generated it. So module, we pass this module into the very, very long module tree. And then I use this visit. But this time, I put in a transformer. So the code will be changed. And I store it as new. When you print out new.code, you will have the new code. So let's see what we have right now. Don't forget to save. Ooh, I have 1 plus 0 plus 2 plus 1. Anytime, anything you put in, it will add a 1 plus. So you always get this wrong. This is what my transformer do. So, conclusion. I think a parser expressing a code in a tree structure is a very good way of expressing your code and analyze it. So we can actually understand how Python interprets our code and make it nicer by reformatting it. And using a reformatter actually will make your code easier to use by a lot of people and to collaborate. So we should learn more about it, or maybe, if you need to, you can write your own. So that's the end of my presentation. Before you go, I want to tell you about PyLadiesCon. There will be a poster, the PyLadies poster upstairs. You can visit, talk to some PyLadies, and support PyLadies. Thank you very much. That's the end of my talk.
Thanks so much for your talk, Chuk. Do we have any questions from the audience? Yes. Microphone's coming.
So hi, thanks for your talk, and this is very cool to review the wheel thing. So I mean, in the beginning you mentioned like there are some other famous tools like BlackRough, and have you checked how they do the formatting things, and is that something similar to what you are working on, or actually there are more interesting things under the hood? Yeah.
Yes, I haven't checked in detail, but this, what I show you, of course, is not the exact tool or exact method that is used by the other formatter, but by principle, it's doing the same. It will break down your code and analyze it, and then restructure it. I know some formatter, for example, iSort, they are actually looking at your code instead of formatting using the syntax tree. It's because I thought it's a very small section. I only changed the import order of your code. So that one, they just look at the code as text. But if you have a formatter that works with a huge section of your code, or every line of your code, I think you will have to express it in a syntax tree. Yeah.
Thank you.
Any more questions? At the front.
Hi, thanks for your code. On the beginning, you mentioned there's AST and CST because CST can keep the space or comment stuff, and our team is now using AST for checking some code. So I'm just curious, would you suggest we try CST, or have you ever have any practical example on where your team are using this kind of tool for linting your source code or something like that? Yep.
Yeah. So again, AST and CST, the difference is the level of details of the code that it represents. So there are different use cases. AST, if you doesn't care about how the code look, because a reformatter at the end, it would generate a new code. So you need to have more detail. That's why reformatter, they will probably, most of them will use something, have more detail like CST. But for example, compiler, because it will eventually become machine executable code. So it doesn't care about the detail or how it got presented to a human. Again, I can't tell you which one to choose. It depends on your use case. How much detail do you need? I haven't write a compiler myself. I have only used libcst in some formatter tools to do some formatting. That's my experience. Yeah.
It sounds like CST is like a superset of AST, but if that's the case, why would someone need to choose AST? Or it's faster or something like that?
As you can see, the output of the parsing is very huge in libcst. So if you don't really care about the detail, it will be an advantage to skip over those. So that's why you use the AST. Yeah.
Okay, yeah, thanks.
Any more questions? Okay, let's give Chuk one more round of applause for a fantastic talk. So just a reminder that the party registration is now open. So if you have a ticket for the party, please visit the registration desk and pick up the wristband. It needs to be done before 5:40.
1, 2, check, mic, check.
Since there's 20 minutes before the talk, if you have a party ticket and haven't collected your wristband, now is a great time to quickly run to the registration desk and do it, and then you can come back. We're going to get started in about 5 minutes. If during the talk you would like to, and we would definitely encourage it, share your experience on Twitter or X or whatever we're calling it now, you can use the hashtag PyCon APAC _2 for this track. Or if you want to send tweets about the conference in general, you can use the #PyCon APAC hashtag. Thank you. So we're about to get started. Today our speaker is Peacock, who's also vice chair of this wonderful event that we have on today. And his talk is Comparison of Packaging Tools in 2023. Before the presentation, Peacock's going to read a statement, which we use as a microphone test mostly, but we'll also give you some extra useful information.
Okay. My name is Peacock. The talk title of my talk is Comparison of the Packaging Tools 2023. My presentation will be in English, and the presentation material in also English. I will publish the presentation materials, and I agree to having my pictures taken during my presentation, and I will comply with the PyConjp code of conduct. Thank you.
The presentation today will be 30 minutes in length, including a 5-minute Q&A, so roughly 25 minutes for the materials and 5 minutes for Q&A. We can either wait a couple of minutes or get started early if you want. I think it's okay. So let's give our speaker a welcoming round of applause.
Okay, thank you for introducing me. Yeah, let's start my talk, comparison of the packaging tools in 2023. Okay. Yes, I have the uploaded slides and yeah, please scan this QR code and open browsers. Yeah, and feel free to take pictures and tweet with me. Okay. Okay. First of all, I will explain why I made this talk and who is target of audience. Okay, at first, my motivation is that here, there are so many packaging tools in Python today. So some objectives and design differences. So if you are not professional for the Python packaging, so it may be very hard to choose which is best one packaging tools. So over the few years, these tools has changed dramatically because of the adapted these PEPs adapted and implementation increased. So there, I will introduce 3 big PEPs. First, PEP 517 is a build system specification format. Second one is PEP 621 standardized PyProject.toml format. And finally, third one is 660 PyProject.toml based editable install, pip install e dot. Okay. So I felt I often ask questions, have questions. Which packaging tool should I use? Sometimes when asked, in the Python community was outside of the Python communities. So I felt needed pros cons based comparison in now. And sorry, please note that all opinions are in my own, since I am not developers of any packaging tools. Okay. Okay. I will compare these tools for the 3 types of the Pythonistas. First, library and framework open source developers. Maybe it's a complex project directory structures. And second one is application developer with many people projects. So as you worked at a company, and with differences of the Python packaging skills. So and then finally is one-shot scripting developers for like a small project, such as automation or networking. Okay. Okay. This is the table contents today. First, I introduced a list of the tools. Second, self-introduction. Then, main topic is pros cons for each tool. I will explain pros cons based tools descriptions. And then, finally, what is the best tool for these 3 Pythonistas? And then, if you might be interesting, I will introduce Rai packaging as an appendix. Okay. There are the tools I will compare today. There are 6 tools: pipm, poetry, pdm, pip tools, hatch, and pip. Okay. There are more features I do not mention today, but I think I have covered of the major and most well-known useful ones. Okay. Let me introduce myself briefly. I'm Yoichi Takai, but as known as Peacock. So please call me Peacock. Okay. Since I'm a developer, December 2022, I have been working at Topgate as ISE infrastructure as a code and DevOps engineers. While my working, I have been volunteer staff of the PyConJP since 2020, and the vice chair since last year, 2022. Okay, yeah, in addition, I'm a director of the PyConjp TV as a YouTube live for director. It held once a month introducing other PyCons or local events. Okay, and my hobbies are listening music, classical music, mirrorless cameras, skiing, eating and drinking. Yeah, I like beer. Okay. Yeah, before starting my comparing tools, I'd like to explain what is a PEP 621 style PyProject tomer. Yeah, I think it's my most important PEPs for this talk. Okay. Yeah, this format is PEP 621 style PyProject tomer. And it's a new standard defining Python packaging metadata and build system dependencies. Yeah, there are three points for defining dependencies. Yeah, first, the build system table. Yeah, highlighted there. Line number 1 and 2. Yeah, it's a build system backend. It's requires setup tools and where. Next, dependencies property in a project table is defining dependencies, yeah, such as SQLAlchemy and FastAPI. And lastly, project.optional dependencies, yeah, two tables are defining optional dependencies as such as develops only, black, frequent, and MyPy. Yeah, but please do not think that the requirement status is dead. Yeah, since I introduced PyProject.tomer only, but requirement status.net not dead. Okay. Okay. Next. Okay. Now let's start comparing main section. I will introduce pros cons for each tools. Okay. Yeah. The first is that PPM. Yeah, it was very famous for the 2018. Also, its popularity seems to have been settled down. Yeah, it's still maintained it. Who doesn't know this PPM? Anyone knows? Okay. It was a game changer for the Python packaging. Yeah, but I will not explain detail a lot because I don't recommend this. Okay. It has a very progressive tool. Yeah, since 2018 appeared, but it forced me the log files and upgrading, adding commands, wrapping virtual envs. But the limited support for the PEP 621 style, I before mentioned for style PyProject.tomer. But I think it's no longer a good idea for the PPM for new projects. Okay. And maybe slow dependency resolver, but I heard that improved. If you know this resolver information, please tell me after this talk. Okay. Next is poetry. Yeah, I remember it becoming famous 2020 maybe, but I think it's still a popular tool. Yeah. How many people you use poetry? Half of them. Okay. if you use this, okay, or the so many people, I think most popular tool, but I will not recommend it. Also, reason is Poetry has many features, but okay. First, I will explain pros. Dependency management with log file, supported also. Needless to say, it was later than ppm, so it's a standard included. And as you may saw, the point of the Poetry was revolutionary. It included the task runner, such as Poetry Run, and helper for the building hoist. And one thing, the concept, it does not support it, PyProject Tomer, PEP 621 style. So it's incompatible for the other packaging tools. So it's migration is very difficult. Okay. And the third one is the PDM. Yes, I have not these tools since made this slide and proposal, but it seems to be very useful tools. How many people do you know PDM? Only one? Okay, I will explain. It has two or three advantages. The first one is fast dependency resolver. It's the latest the tools I will introduce. I think but you can choose another backend to the dependency resolver. Next point, it supports the PEP 621 style PyProject Tomer. So because the most last previous tools, ppm and Poetry, were not supported and limited supported. So, but PDM supports already supported, so it's a big advantage. So its format standard by PEP. You may transfer the tools easily, and then similar to Poetry, includes the task runner with PDM run and included package publisher. And I think one drawback. It's as you know, few GitHub stars, not famous maybe. Okay, so there are few knowledges and know-hows enough to use. Okay, fourth is the pip tools. Please note that the following tools are pip tools and hatch and pip. We are not all included tools, or not all-in-one tools, but only these limited function, limited features. Okay. Pip tools is very simple. Only two commands: pip compile and pip sync. It and also supported PEP 621 style PyProject Tomer. And one more advantage is that maintained by Jazz Band community. So it's maintained Django utilities by the Jazz Band community. So I think governance is the community is very important. So it's not the single author project, not maintained by community. So, but needless to say, it does not include task runner, whole builder, and package publisher. So I will recommend it, use it hatch with next one. Okay. The fifth is hatch. I will just introduce other than pip. It was published very recently and maybe interested many folks. Okay. Yeah, it's very configurable and to the backend building project. You can use it as a tools like pip tools. Yeah, and it's a maintained activity, PyPA, Python Packaging Authority. I think nearly official. Because it's a newcomer, yeah, of course, it works with a PyProject autonomous spec and the PEP 621 style. But I think, yeah, configurable equal to the complex. You will need read and understand the documents and the setup tools or hatch, yeah, this one. And also, it does not, maybe does not include it, maybe package dependencies updater and log file. So please use this with pip tools. Okay, the last one is pip. Now it may be not needed to explain details, yeah, but I will introduce briefly. Okay, goes without saying, I don't know Pythonist who hasn't used this, yeah. Since ensure pip modules is built in Python, so you can use pip as a built-in tool. Yeah, since it's maintained by PyPA and PyProject autonomous spec, and please note that pip is not packaging tool, just a packaging installer setup tools. Yeah, I'm sure and all know cons too. It does not include it virtual env wrapper and not supported file managed dependency and task runner whole builder. Okay. Yeah. Now finally, what you'll be waiting for? Yeah. I will introduce the best tools for the 3 types of the Pythonist use cases. Okay. Yeah. First, if you are a library developer, I will recommend it Hatch. Yeah. I recommend it the use with the pip tools managing dependencies. And you should be understand pip tools, pip backend to what you choose and tools, documentation and specification. So it's maintained by actively PyPA. So I think a good idea to work on the project. And surely it works PyProject autonomous specs with a new standard format styles. Okay. The next one, yeah, it's maybe the production as a working, the application developing. Yeah, I think it's needed. I recommended PDM, so there are many people doesn't know PDM, but only one, only you. And I recommended PDM. Think it's needed to everything is included and easy to use. It will be especially valuable if you are developing large project or with many Pythonists and different skills, many people. So it's easy to use. The reasons yeah, you can use it PyProject Tomer spec, and it has a task runner for the testing, and like the node npm projects, npm scripts, yeah, and maybe there are a few knowledges and know-hows, yeah, but I think it's worth a try. Yeah, you should try it. Okay. The last is just use pip only for lightweight project. Yeah, the first is suitable for the large project or the complex directory structures. Yeah, but yeah, this case is not needed for the complex projects. Yeah. So I think that it's better to small projects, yeah, lightweight and non-dependency to install itself. Yeah, if not to the rate to the switch to PDM, so when you feel it is becoming too complex, when you feel the too complex to the managing with pip, so to not rate. Okay. Okay, conclusion. And it's a summary to best for you. Yeah, library developer for Hatch, application developer for PDM, and scripting developer is pip. Okay. Okay, main section is over there, and the appendix, okay? It's engaged last half year, I think, summary in my opinion. So it's written by Armin Rocher and known as Flask, the Mitsuhiko, who is famous for Flask, Jinjatsu, Click, and more. Okay. Process here. Single binary, easy to install and use. And works with PyProject Tomer, and almost what you want is included. Virtual developer, package publisher, builder, and included also Python version manager, and which Python versions to use, switching Python 3.11 or 3.12 or the 3.9 or 3.10. Okay. Yeah, concepts are needless to experimental, not stable, too early to use. Yeah, and his personal projects, and just I think considering just wrap over pip tools for the dependency manager. For maybe if you know the details for this issue, this topics for please discuss about this is there. Okay. Yeah, this is notes for referencing. Okay. Yeah, thank you for listening so much. That's all from my talk. Yeah, and finally, I'd like to say thank you for the PyCon APAC participants and speakers, volunteer staffs, and your listeners. Yeah, I hope that have you a great time for the PyCon APAC 2023. Okay, thank you. Thank you so much.
So we're just going to come and steal the microphone from you to do the Q&A.
Questions?
Questions? Lots of them.
Oh.
Thank you for your comparison about these packaging systems. So if I understand correctly, so I think your recommendations came from the current features of each systems rather than kind of the long-term vision, because I couldn't know which projects are still active, or maybe one project could be dying, right? So in terms of the long term, is there any recommendation, or your recommendation is still same as for example, like PDM is, maybe this is not famous. I don't know if the project is still active or dying, but yeah, like what do you think about the long-term vision?
It's maybe the difficult question. Yeah, I think PDM support is PEP 621 style, and for the compatible for the other tools, yeah, you can transfer easily from the PDM to other tools. Okay?
Right. Any more questions? I know we had some. So.
Hello. Thank you for your comparisons. That was insightful. I was just wondering, because you only had one negative for poetry, which was the support for the 621 PyProject TOML style. If they added that, would your recommendations have changed? And if so, how?
Yeah. Yeah, so poetry not supported, but still, maybe the discussion is ongoing work in progress for the not needed to the transfer like the PDM. So the so I will wait for the support PEP 621 style. Okay.
Sure, but if they had that, would you then use poetry instead of Hatch or PDM?
Yeah, poetry is not official. Yeah, just a third party. Yeah, so if you use a library scripting library framework, yeah, so long-term maintain to the I will recommend it Hatch. Thank you.
More questions? I know we've still got time, so, and I know there were a few other hands. Anyone else? Right at the front.
Hi there, thank you very much for your talk.
Thank you.
So if you have something like Docker, maybe I'm missing something, but in a Docker container, if you're pip installing your requirements in, if you were to change from using pip to something like PDM, what would you actually gain?
Requirements.ini.
So
maybe the works with without the requirement dependencies property for the here for the compatible for the requirement tickets. It's or the if you use requirements.ini or requirements.txt, yeah, it's maybe the opt-out here. It maybe works.
Okay.
Okay.
Thank you.
Just to add, if you don't mind, the other thing is that there's no lock file support doing it that way, so reproducible builds become more problematic. But otherwise, yeah. Any more questions? Yes.
Okay.
And then one more at the back. I think we may only have one. We'll see how we go.
It could be a pretty naive question because I'm the old guy who prefer setup tools and pip for maintaining the library. But in some use case, you have to maintain a library based on the vendor library that have a modified version. That if I don't want to upload the vendor library to the PyP package, then in that case, what do you recommend to maintain this kind of library?
So just the pip tools, pip with setup tools, cannot upgrade easily for the non-file managed dependency. So I would recommend it with use the pip tools with pip sync and pip compile for the it can be used file managed dependency. So
so you recommend Hatch?
Yeah, recommended Hatch or the Hatch with pip tools. Okay.
Okay, thank you.
Thank you.
Okay, that's all we've got time for. Can we have a big round of applause for Peacock?
Thank you so much. Thank you so much.
If you've got any more questions, you can hopefully catch him in the corridor quickly, but please, we ask for cooperation to not come up to the front of the stage, as we've got to prepare for the next speaker. Our sponsors, I think they're still running the rally for the towel, so please go visit them and collect stamps and collect your PyCon APAC towel. And just a reminder that the party registration is open, so if you haven't collected your wristband and you do have a ticket for tonight's party, please visit the registration desk and collect your wristband before 5:40 p.m. Thank you.
Thank you.
Hi everyone, we'll be getting started in about 5 minutes. During the talk, if you would like to tweet about the track, please use the hashtag PyCon APAC_2. And if you're tweeting about the conference in general, then hashtag PyCon APAC. Okay, we're about to get started. The speaker for this talk is Uma Anamalai, and the title of the talk is The Best of Python, a review of some of its slickest features, which sounds kind of awesome, to be honest. So just before we start, I'm going to have Uma read a statement as a microphone test, which you've probably all heard about 1 million times so far in the conference. So if you want to start with that now, you might want to flick the microphone on.
Oh, thank you. Okay. My name is Uma Namle. The title of my talk is The Best of Python, a review of some of its slickest features. My presentation will be in English. The presentation materials are in English. I will publish the presentation materials. I agreed to have my picture taken during the presentation. I will comply with the PyConjp Code of Conduct.
Thank you. So the presentation time is 30 minutes, including 5 minutes of Q&A, and I'm sure you've all heard this so many times. I know I've said it. With that, I think, yeah, we can get started.
Okay, cool. So thank you for joining. So yes, today we're going to be talking about some of the best of Python. We're going to be reviewing some of the language's slickest features. And a little bit about myself. So I'm a software engineer on the Python agent team at New Relic. I've also worked at software companies in the healthcare and marketing industries, as well as hardware at Oracle. I've done research related to the newcomer barriers that people face when they join open source software projects. And this is my 3rd time attending PyCon. My first 2 were PyCon US, and I got to speak at PyCon US this past year. So today we're going to be talking a lot about syntactic sugar. So I like to think of syntactic sugar as the quirks of a programming language that allow us to write concise and readable code. Now, most programming languages have some version of syntactic sugar, and fortunately for us, Python has a lot. It's important to understand syntactic sugar not only because it helps us to write more extensible and flexible code, but it also helps us to read code better. Because of how prevalent syntactic sugar is in Python, it's important to be able to recognize it and understand what it's doing under the hood. So today we're going to be talking about 4 concepts in Python: decorators, context managers, list comprehensions, and magic methods. So if you're a newcomer to the language, we'll be walking through some simple examples here. Okay, so we're going to start by talking about decorators. So what exactly is a decorator? So a decorator is a function that allows us to change the behavior of another function. The key thing about it is that we can change behavior without changing structure. And the way this works is through implementation of function wrapping, which we'll look at in a minute. Decorators return closures, which is how we're able to modify what a function does without actually changing it. So you might have actually noticed decorators being used throughout the language because Python has multiple built-in decorators already. For example, there's the @class method and @static method decorators, which allow us to turn a function into a class or static method, and depending on whether you want it bound to your class. And then we can also use the @property decorator to turn a function into a property accessor. So as we talk about this, it's important to remember that everything in Python is an object, including functions. And because of that, functions have certain properties that allow us to really implement decorators. So for one, we can store them as in variables and in other data structures. That means that if you have a dictionary, for example, you can actually store a function as the value in your key value pair within that dictionary. You can also pass them around to other functions, so they can be used as arguments, and they can also be returned from functions as well. And all of these properties are important because we rely on them when we create decorators. So before we can talk about decorators, we need to understand what a closure is. So what we see on the screen here is a simple example of a closure, and it's essentially a nested function. So what this is doing is we have a function convert weight, and nested within it, we have another function, convert to pounds. Now, convert to pounds is doing a simple calculation to convert kgs to pounds, printing out the conversion, and then it's going to return convert to pounds. If you note, convert to pounds is not being called, it's just being returned. In order to actually call it, we have to come and set up our new variable converter, in which we call convert weight with 100 passed to it as the kilograms we want to convert. But what we notice here is this is just going to store convert to pounds in converter. To actually call convert to pounds, we actually need to make a call to converter. And the other thing to note here is the kilograms variable. So kilograms is being passed to convert weight, but it's not actually being passed to convert to pounds, yet we're still using it. So that's an important concept with closures. The inner function is going to have access to the variables defined in the outer scope, so we can still do our calculation even though kilograms was passed on the outer level. So if we run this code, we're going to get our conversion done for us. 100 kilograms is 220 pounds. So this is a closure in essence. So now we want to actually bring a decorator in. So what we're going to do first is we're going to modify the way we're getting our kilograms. And we're going to do that by letting our user tell us how many pounds they would like, or excuse me, how many kilograms they would like to convert to pounds. So here we're going to take user input, ask them how many kilograms they want to convert, and then we're going to return that user input. So now we have a way to get our kilograms, and we're going to come back to that original closure and modify it. So what we're doing here is instead of passing kilograms in like we were doing previously, we're now going to pass in an actual function, and that function is going to be our input function. So again, because of what we talked about before, functions can be passed as arguments, and because of the concept of a closure, the function can be called within convert to pounds even though it was passed into the outer scope. So now this code will execute as expected, and we can still get the same output. So now let's put it all together. So we have our modified closure now, which takes in a function, and then the function it's going to take in is get input weight, which is allowing us to let the user tell us how many kilograms to convert. And then we do our actual conversion. So this time, we're going to pass get input weight in as the argument to convert weight. And then we're going to call converter, which is going to actually execute convert to pounds. So when we run this, we get the same output, but this time our user told us that they wanted to convert 100 pounds to kilograms. But it's the same concept. So now that we understand this, we can bring the syntactic sugar in. So that's done with the @ syntax. So what we have here is our convert weight decorator now being automatically applied to get input weight with the @ symbol. And so this goes back to what we talked about previously. We can now call getInputWait with no modification to the function, but now all that conversion logic we just wrote is automatically going to be applied because we're applying it with that add syntax as a decorator. The cool thing about this is that we can actually now use this convert weight decorator to do any type of conversion from kilograms to pounds, and it doesn't have to be used on just this function. Maybe you were looking through a healthcare database and you have patients and their associated weights in kilograms. If you wanted to do a conversion of those kilograms to pounds, you can put this same decorator onto that example, and you wouldn't have to modify the way you're actually getting your data out of the database. So now we have this piece of extensible code that can be used in many different ways. But there's many uses for decorators beyond what we just looked at. So a common example is testing. At New Relic, we use decorators a lot to write validators. So we can encapsulate the assertion logic that we would like to apply to multiple test functions, and we put it into a decorator that we just apply to all of our relevant test functions. If you've used PyTest before, then you've probably seen that they have a suite of decorators, such as pytest.fixture. So if you want to turn any function into a fixture that can be reused within your test suite, that is done with the decorator as well. Also with error handling, if you have a certain behavior or a log message you'd like to print based on certain errors, you can encapsulate all of that into a decorator and apply it to any function you'd like error handling done for. Function timing is another case. If you want to start and stop a timer to see how long your function took, you can do that with the decorator, so you don't have to manually do your timing in every function you would like to time. And in general, any repetitive option or repetitive operation might benefit from a decorator, given that this is going to allow us to deduplicate our code by encapsulating logic into a function that we can apply across multiple use cases. And there's a ton more uses for decorators, so it's worth seeing if your code could benefit from one. So the next topic we're going to talk about is the context manager. So when we talk about context, what we're really referring to is the state surrounding a code section, and that can be in the local or the global scope. So we're going to talk about this in the example of a try finally pattern, because this gets us to getting towards a context manager. So we're going to look at it in terms of file I/O. So what our try except is doing here is it's basically letting us open a file, test.txt, in the read mode, and we're going to store that into our file pointer f. Then we're going to print out the lines in that file pointer, and then we're going to come into our except statements. So maybe we want to check if that file was not found, and then we want to print out that exception. Maybe we also just want to have a general blanket exception to cover any case, and we want to print that and then return it as well. So the key about this is that no matter what happens in our try except, whether we hit an exception, whether we hit a return statement, our finally is always going to execute and take care of cleanup for us. So in this case, we're just going to print in our finally that we're actually closing our file, and then we're going to call close on it. So this gets the job done, but it's a bit cumbersome, and it's harder to manage data in the scope that we care about. So let's convert this to a context manager. And you can see immediately this is much more readable, fewer lines of code. And we know this is a context manager because we see this with statement. The with statement is helping us set up the context. And for us, open is the context manager that actually is built into Python. So what's actually happening here? Well, on our with line, we're basically entering and creating the context that we're going to be using for our code execution. We store that context in f with the as statement helping us. Now, f is going to be our file pointer, but it's also our context variable. So now that we have that, we can actually go in and do our code execution, and we can use the context variable that we just created. So now we can use that to read the lines out of our file again and print them out. And now we don't even see anything happening here because it's all encapsulated for us, but once we leave the context of this context manager, we actually have auto cleanup being done for us. So that means our file pointer is being closed without us having to do anything. And this is built into Python's context manager for open. But this makes everything a lot simpler. And we can actually go in and create our own context manager to kind of mirror what we just did, and we can use the context manager protocol to do that. So the context manager protocol is all about defining what you would like to happen when you enter and exit your context. So here, as we said, we're going to remake that context manager for file I/O. So in our initialization function, we're going to take in the name of the file and the mode that we would like to open it in. And those are passed to our class constructors. So we can now initialize our class instance with the name and the mode. And then we also are going to set up a new variable self.file, which is going to act as our context variable as we go forward with this. So we have our setup done. And now we come into our enter. So enter is letting us define what we would like to happen when we enter our context. So what we would like to do is set up the context by opening that file that we just passed into the class constructor. So that's going to be self.name and self.mode being passed in, and we're just going to call Python's open function. So now self.file is storing that, and we can return it from enter so it can be used as the context variable for our actual code's execution. Then we come into our exit. The cool thing about exit is it's actually going to handle exceptions for us as well. So we pass our exception type, exception value, and the traceback all to exit, and this will help us to identify if we actually hit an exception when the code executed. So here we're printing that we close the file, and then we print our exception type to identify whether an error actually occurred, and then we call close on our file pointer. Now we can return true or false from exit based on the behavior we would like to see with our exceptions. So in this case, we're returning true because I would like to silence my exceptions. But if I returned false from this, that would propagate your exceptions upward. So you can control the behavior based on what you return from exit. So all of this is going to allow us to do what the built-in context manager just did, but now we can add our own customizations to it by re-implementing enter and exit. So there are many times you would want to consider using a context manager, but there are certain patterns you can look out for to kind of help you make that decision. So if you ever are opening and closing something, like we just saw with the file, maybe you're also opening or closing a database connection, it'd be worth considering using a context manager to encapsulate the opening on enter and the closing on exit. Maybe you're starting or stopping a timer. Again, you could start the timer on enter and stop it on exit. You could acquire a lock on enter or release it on exit. And just any general pattern where you're entering something and exiting something lends itself very well to a context manager's use because that's exactly how the context manager protocol is defined. It's with an enter and an exit. So now we're going to talk about list comprehensions. So as a reminder, a list is a data type in Python. It's mutable, it's ordered, and it's iterable. So it's mutable in that we can change it, we can add to it, remove from it, append, delete, any of those. We can also say it's ordered because we can access the elements in it via an index. And it's iterable, which means we can iterate through it, which is what we're going to do in our first example here. So this is a very simple example where we're just going to go in and define a list of Japanese cities, and what we want to do is make a new list that uppercases all of the letters in all of these cities. So to do that, we've initialized a new list to uppercase Japanese cities, and then we're going to come in and loop through our Japanese cities, and we're going to append the uppercase version of the city name to our new list. Now we do that with city.upper. So this is a very simple operation, and it gets the job done. So if we print out our new list, we get the exact same thing, but now everything is capitalized. So that did exactly what we wanted it to do. But we can do it again, and we can do it with fewer lines of code. And this is where the syntactic sugar comes in, with a list comprehension. So now, again, we have our same Japanese cities list, but this time we're going to use a list comprehension to actually set up that new uppercase city. So here we're going to actually be able to initialize and iterate all in the same line. So we see our brackets on the uppercase Japanese cities, which is telling us that this is going to be a new list. City.upper is our is how we're going to modify the elements that we're putting into our new list. And then we actually do the iteration and get our cities by going through all of the cities in Japanese cities. So now if we print this out, we get the exact same result. So that was definitely slicker, but was it actually faster? So to test this, we're going to use a simple example where we start a timer and we initialize a new list. And what we're going to do here is we're going to go through all of the values in the range 1 to 1,000,000, and we're going to append those values to our new list. So if we end our timer and print out our value, well, we're going to get 0.225 seconds. Now, if we do that again, but this time we use an actual list comprehension to handle the initialization and appending all into one convenient line and start and stop our timer, print that out, now we get 0.157 seconds. Now, this was a straightforward operation, but the performance impact can be even greater based on how complex your operations are. So in terms of the benefits to a list comprehension, for one, it's going to improve your code's readability. When we do use a list comprehension, we can focus more on what the values are that are going to be in our list versus how they're going to get there. We don't have to put the emphasis on initializing our list and manually iterating. And instead, we can put the focus on what that new modified value is going to be that's going to be added to our new list. And it also gives us reduced overhead. And so the potential for faster execution time is definitely there with the list comprehension, besides it being more readable. Now, our final topic we're going to talk about is the magic method. So a magic method is basically a method that is internally invoked for us by Python, and it's done for us based on the operations we're using in our own code. The way we can identify it is with a double underscore that's appended and prepended to the function's name, and it's represented also as dunder methods. So let's look at a popular one that most people have probably seen before, and that's dunder init. So we have a class user, and dunder init is basically initializing our new class instance. We have self, name, and age passed to it. Now, name and age are going to be passed directly to our class constructor. But self actually is cool because it's being created by another magic method under the hood called dunder new. Dunder new actually creates the class instance, which is represented by self, and then dunder init actually initializes that class instance. So here we're just going to set up our instance to store the name and the age that was passed to our class constructor. And now that's available when we create our new class object, PaulUser. And it's quite easy to check for magic methods on an object if you're ever curious to know what's available to you. So you can do this by making a call to dir on whatever object you'd like to check for methods on. So this is a method that allows us to see the methods and the properties that are available on your object. So here we tried it on the string hello, and we can see there's a ton of magic methods already available to us. So a lot of them have to do with string comparison or attribute accessing. And the magic of the magic method really is everywhere. There's many cases where there's a magic method being used under the hood and we may not even realize it. So for example, if we try to check len on a certain string, we want to get the length of that string. That under the hood is going to call dunder len, which in turn is going to return to us the number of characters in that string. There's also dunder contains, which is invoked for us automatically if we use the in operator. So if I want to know how many, if a certain string is present in another string, dunder contains will be called under the hood, and then that's going to return true or false based on whatever was searched for is actually present in your string. Then there's also dunder call. Now, dunder call allows us to turn class instances into callables. We can treat them as functions almost because dunder call is invoked under the hood when we actually make a call to it. And then another important thing to talk about with magic methods is operator overloading. So let's look at an example of how the same exact method is implemented in 3 separate ways based on the class it's used in. So dunder adds is going to be invoked when we have our plus sign being called under the hood. So our first example here is 2 integers. If we add 2 integers together with the plus sign, we're going to be getting the sum of them, and that's because of the way that dunder adds is implemented on the int class in Python. Now, we can do the same thing again, but adding 2 strings together, and that's going to concatenate them, and that's because there's a completely separate implementation of dunder adds on the string class. Now, the same concept goes for lists. We can add 2 lists together to join them, But again, there's a completely different way that dunder adds is implemented for lists. So given that we can make changes, let's actually try to change a magic method ourselves. So here we have that same user class, and I want to actually try to print out what our user object looks like. So if I call print on Paul user, well, I get something that's not very readable. This is supposed to be string representation of the object, but it doesn't tell me any actual valuable information about that user. So I want to change this by re-implementing the dunderStir class, or dunderStir method. This method is going to allow us to customize the string representation of our class object. So I would like to actually know the username and the age of the person that I'm representing with this class object. So I'm going to return a formatted string with that information, and if I print that, now I get their name and their age, and this is much more useful if I'm trying to compare class objects, because I know what's being represented by it. So why should we actually bother to modify a magic method? Well, it allows us to implement operator overloading, which helps us to customize the predefined methods that are already present by extending the functionality they have, which means we can change the predefined behavior of a function. And different classes can define the same method differently, as we saw with dunder adds. And this is really helpful if we're trying to do object-oriented programming. Now, everything that we've talked about here is connected. You might have noticed that magic methods were actually discussed already in the context manager protocol with dunder enter and dunder exit. Dunder enter and dunder exit are the keys to the context manager protocol, but all that means is that we're just taking the magic methods on a class and we're just customizing them to do what we want for our own use case for our context manager. And then there's also the context lib module, which we didn't talk about today, but it's a module that allows us to create our own context managers by applying decorators. So there's a decorator context lib.context manager that we can apply to our generator functions to turn them into context managers without actually modifying the generator function itself. So a lot of these concepts overlap, and you'll see that more. Just to wrap things up, it's important to be mindful of the design patterns that you choose to implement. Sometimes the same pattern can get the same result, but it's up to you as a developer to decide what makes the most sense for your use case. For example, you could implement function timing with a decorator or a context manager, but based on what your code's doing, one might be more preferred. And then we also have the important idea that syntactic sugar may not always be the answer. Even though it's cool and it's slick, sometimes it's better to be more explicit in your code. And it's more to think about who's using your code and for what purpose. Is it going to be open sourced? Is it an internal tool at your company? Whatever the reason is, you should think about why it's going to be used and how, and make your calls based on that. And with that, thank you.
Thank you so much for the talk. Do we have any questions for Uma? Yes.
Yeah, maybe just now you mentioned like more explicit, right? To me, like seems there's many magics. Like we don't know. Actually, the internally called the init first or the new like exit as well as the finally, right? And then the other things is like how do we know like the print without the stir will print the like function information. Yeah, that kind of information basically. Is there any list or documentation we can refer to?
So for magic methods, a lot of these things are documented in Python's official documentation. When it comes to being explicit, it's harder with magic methods because the point of them is to not be something you have to worry about because it's implemented under the hood for you. So when it comes to the magic method specifically, it's something that if you would like to see a change in the behavior that's automatically being invoked, you will need to make a change. But if you're looking at a different concept like a context manager or a list comprehension, it might be better to actually do the traditional approach instead of getting too fancy in your code if it's based on the use case.
All right, thank you.
The one at the front.
Hello, thank you for your talk. So I'm coming from more of a C and C++ developer. right? So I was very surprised when I first saw list comprehensions, for instance. I wasn't like, have no idea that that existed in Python. So my question is, how would you recommend to kind of learn these new things in Python, like list comprehensions, context managers, and stuff like that?
I think when it comes to learning these concepts, what's more important to understand first is the traditional way of doing it. So with the list comprehension, making sure you really understand how to do list iteration in that traditional way with the for loop. And if we go immediately into the syntactic sugar, it can just get confusing because you need to understand what it's actually trying to accomplish. So I would say most of the examples we looked at, we kind of saw the original or maybe more cumbersome way of doing something, but you should try to learn that approach first before you go to the syntactic sugar approach, is what I would say.
Okay, thank you.
Have we got any more questions? No? Going once? Going twice? Okay. Oh, yeah, we have one more.
Thank you for your talk. Everything is so useful for us, maybe. Do you have anything you cannot add to this presentation, but it's so useful as you know, writing the Python code?
Sorry, what was that?
So if you have anything you cannot add to this, you cannot talk about in this presentation, but you think it's useful.
Yeah, actually, when I was writing this, I initially was wanted to talk about descriptors. That's another protocol, and it helps us with attribute access. So that's what I actually wanted to do here, but it would have taken half the presentation itself. So descriptors are also important, I think, because attribute access is so important in Python to understand how you're actually getting an attribute off of an object. So that's definitely one I wanted to talk about today, actually.
Thank you so much. Thank you.
We've got time for one or two more questions if there's any. No? Okay. Can we have a big round of applause for Uma? So just a few housekeeping things. Again, you've probably already heard this a few times now. Party registration is open. You have just over an hour left to pick up your wristband if you have a ticket. And if you do, we'll see you at the party. Also, the lightning talks start in about 10 minutes in track 1 room next door, along with the closing. And I think the sponsor booths are still open. So if you can squeeze a visit in with them, if you haven't seen them all already, that'd be really great. Thank you.